Hi everybody, welcome back to my channel. Today we're going to be going over fractions 2.0 is what I'm calling it. Basically, this is the second video in my pre-algebra series focused on fractions. Last time, my previous fraction video focused on kind of the definition of fractions, what a fraction is intuitively, and how we kind of compare two fractions to one another. Now we're going to be going a little bit more in depth on the understanding of fractions, focusing on the definitions, proper versus improper fractions and mixed numbers, equivalent fractions, simplifying fractions, finding their greatest common factor, and doing the basic operations with all types of fractions like addition, subtraction, multiplication, and division. So let's get right into it. First off, proper versus improper fractions. What is a proper fraction? Well, as we discussed last time, all fractions have a numerator and a denominator, right? So for the example, the fraction 1/2, 1 is its numerator, and number 2 is its denominator. Basically, this is just how we describe the part, which is the top, and the bottom, which is the denominator, which is the whole. So basically, a numerator is the amount of pieces. The denominator is the total number of pieces in the entire pie, right? So for example, let's say we had a pizza like this, right? And we cut it into two pieces, right? 1/2 describes, well, this one piece on the side. 1 is the number of pieces shaded in, or the number of pieces eaten, right? And 2 is the total number of pieces in the pie. So if we were to say something like 3/8, what this is saying is if we'd have our pizza right here, split it into 8 equal pieces, right? Because that's what the denominator is talking about. And then we eat 3 of them, okay? So that's 3 pieces, okay? So that's what a numerator and denominator is. But what is what we call a proper fraction? Well, a proper fraction is any fraction where the numerator is less than the denominator. So basically 1/2 or 3/8 or 15/16 or 1/273, these are all proper fractions. Right? A proper fraction is wherever the top is less than the bottom, and the numerator is less than the denominator. We call these proper because we can describe them in one image, right? We can say, we can draw one pizza, and we can draw 3/8 of a pizza like we did here. We could even draw 1/273 of a pizza. It would take a lot of slices, right, and a lot of precision, but we could draw it, right? Now, what do we mean by an improper fraction? Well, an improper fraction is the opposite of that. It's a fraction where the numerator is larger than the denominator. For example, 7/4 or 23/17. Okay, this is an improper fraction because it's more than just one pizza. It's more than just one whole, right? So if we look at something like 7/4, for example, we have, this is our pizza. We're splitting it into how many pieces? Well, the denominator tells us we're splitting it into 4 pieces. Right? But we have 7/4. We see clearly that we can't eat 7/4 of this one pizza. So we have to draw the second pizza in, cut it into fourths, and then we have to eat 3 more of these, right? So an improper fraction is a fraction written where the numerator is larger than the denominator. Okay, but there's one more definition of a fraction that we need to go over. Okay, let's move this up really quickly. So yeah, that one more definition is what we call a mixed number. Oops. A mixed number. And what a mixed number is basically the better way of writing an improper fraction. What do I mean by that? A mixed number is where we have both a whole part and a fractional part. So 1 3/4, that's a mixed number. 7 2/9, that's a mixed number. So what does this 1 3/4 or 7 2/9 actually mean? Well, what this says is 1 3/4 is just one whole pizza plus, that we've eaten, for example, plus another pizza with 3 of the 4 pieces shaded in. This would be 1 3/4. This is the 1 part, and this is the 3/4. And we call it a mixed number because it includes both whole numbers and fractions, a mixed number. Right? So if we notice something here, this size is exactly the same as this thing that we drew up here. So what we've realized now is that 7/4 written as a mixed number is just 1 3/4. Okay, and we can see this visually, right? This is 7 quarters of a pizza, right? Written visually right here. This is 1 pizza and 3/4 of another pizza written visually, and they're the exact same. So how do we kind of convert between these improper fractions and mixed numbers? Let's discuss that real quick. So how do we convert between these improper fractions and mixed numbers? I've kind of put this off to the side, so we still have it as a reference, but we have some room. Okay, so to convert between improper fractions and mixed numbers, let's say we have an improper fraction. For example, 9/2. Okay, this is improper because our numerator is larger than our denominator. 9 is bigger than 2. Okay, now how do we convert this to a mixed number? Well, here's what we do. We basically have to figure out how many pieces make up whole pies in our improper fraction. What I mean by that is, let's visually represent 9/2. Well, 9/2, that's just 9 halves. So we cut pizzas into halves until we have 9 individual pieces. 1, 2, 3, 4, okay, 5, 6, 7, 8, 9. Okay, so that's 9/2 written visually. Well, how many whole pizzas do we have? We have 1, 2, 3, 4 whole pizzas, and we have a remaining 1/2 a pizza. So to convert 9/2 to a whole number, we just are left with 4 and 1/2. And this works with any strategy. To start off practicing this, it's good to try to draw it visually like we did here, but eventually you'll get better and better at figuring out how to find the mixed number whole part without having to draw these things out. For example, if I was doing 37 sevenths, a good way to do this would be to do 37 divided by 7. And what this gives us is 5 remainder 2. Now, what can I do with this information? I know that there's going to be 5 whole pizzas, right? 5 whole pizzas when we draw it out, and we're going to have 2 slices left on another pizza. So if I wanted to convert 7/37ths to a mixed number, I could write it as 5 and 2/7, where this is the divisor part, or the whole number we get when we divide, and this number is the remainder we're left with, and this is the thing we divided by. Okay, so that's how we convert between improper fractions and mixed numbers. Okay, now let's talk about simplifying fractions. So there's a lot of fractions that we can write that can be simplified, and here's what I mean by that. Let's say we write the number 8/24. This looks like a normal fraction, but let's draw it out and see what we get. 24 is a little bit difficult to draw, but I'll give it a shot. There, 24 slices, okay? So now we have 24 slices, and if we were to draw in 8 out of these 24, we would be left with 1, 2, 3, 4, 5, 6, 7, 8. Now let's draw in another 8 out of 24 just to see some kind of pattern here. 1, 2, 3, 4, 5, 6, 7, 8. Now let's draw in one more set of 8 slices. 1, 2, 3, 4, 5, 6, 7, 8. That's interesting. That's all of the slices. So when we can think about that, that makes sense because we have 8 here, 8 here, and 8 here. Well, what does that mean to us? Well, we know that 8/24 plus 8/24 plus 8/24, that's going to give us one total, or just 24/24, which makes sense. But it also tells us that, let's say we're dividing this pizza into to 3 people, right? The person 1 gets the red slices, person 2 gets the green slices, and person 3 gets the purple slices. What we know now is that they each get 8 slices, and they each get the same amount, right? So let's imagine we didn't have to cut the pizza into 24 slices. We could have just cut it into 3 equal slices like this, where each person would get the same amount of pizza, and they'd each get 1/3 of the total pie. Okay, now what does this tell us? It tells us that 8/24, when we cut the pizza into 24 pieces and eat 8 of them each, that's the same thing as cutting the pizza into 3 slices and eating just 1 of them. Meaning we can say that 8/24 is equivalent to 1/3. Now, how do we do this mathematically without having to draw it out every time? Well, we can simplify 8 over 24 to be 1/3 with the following strategy. We need to find out what's called the greatest common factor of 8 and 24, the numerator and the denominator. Now, if you want a full breakdown of how to find the greatest common factor, I did a video in the past on factorizing and factors and multiples. So go check that video out. But for now, really briefly, we just basically what a greatest common factor is it's the largest number that is a factor of both 8 and 24. Well, what are the factors of 8? 1, 2, 4, and 8. Okay, and what are the factors of 24? 1, 2, 3, 4, 6, 8, 12, and 24. So what is the largest number in both of these lists? Well, 8 is in both of the lists. That's the biggest number. So our greatest common factor of 8 and 24 is 8. Now what we do is we just take 8 over 24 and we divide each number by that greatest common factor. We're going to divide each number by that greatest common factor. That's going to leave us with 8 over 8 is just 1 and 24 over 8 is just 3. And that gives us a simplified version of 8 over 24. Let's do another example to make sure that's clear. Let's say we want to simplify the number 9 over 24. We'll say 9 over 24, okay? So now there's 9 slices out of that 24 pizza instead of 8. Okay, how do we simplify this? Well, can we simplify this? First, we need to find whether there's a greatest common factor of 9 and 24. Well, what are the factors of 9? 9 has the factors 1, 3, and 9. What are the factors of 24? Well, we said there were 1, 2, 3, 4, 6, 8, 12, and 24. Once again, go back and check my video on factors and multiples if you need some help figuring out what the greatest common factors are. Okay, so what is the largest number in both of these lists? Well, I see the largest number, well, it's not 9 because there's not a 9 in this 24 list, but there is a 3 in both lists. So that's the greatest common factor between 9 and 24. So how are we going to do this? We're going to simplify by taking 9 over 24, and we're going to divide each number by our greatest common factor, 3. That's going to give us 3 in the numerator and 8 in the denominator. So 9 over 24 can be simplified to be 3 over 8. So if I cut a pizza into 24 slices and give one person 9 of them, that's the exact same as cutting a pizza into 8 slices and giving that same person 3 of them. They're getting the same amount of pizza. Okay, so that's kind of a discussion of proper versus improper fractions and how to simplify fractions. Let's actually get into how to add, subtract, multiply, and divide fractions now. So adding and subtracting fractions is fairly simple once you get the fractions into the proper format. For example, I can add 5 over 12 plus 2 over 12 very easily. Because when they have the same denominator, that's just giving me, well, that's a pizza with 12 slices like this. Whoops, it should look more like this. How many is that? 1, 2, 3, 4, 5. Oops, I need one more. There we go. So that's like having a pizza with 12 slices. And starting with the first 5 like this, 1, 2, 3, 4, 5. And then adding 2 more, 6, 7. Now we can add those up and we get 1, 2, 3, 4, 5, 6, 7 slices out of the 12. So 5 plus 2 over 12 is equal to 7 over 12. That's fairly straightforward. Adding works exactly the same with slices as it does with whole numbers. Now, what if we're faced with this issue? What if we're faced with something like 3 over 4 plus 13 over, we'll go 32. How do we do something like this? Now the slices are different sizes, so we can't just directly add them up and get left with one fraction. So how do we add these two? What we need to find is a common denominator. So we call this a common denominator. Okay, and I introduced this briefly in my previous fractions video, but let's go through it in a little bit more depth today. In order to find a common denominator, what we need to do is we need to find what's called the least common multiple of the denominators. That's how we find the lowest common denominator. Now, what is a least common multiple? Once again, go back and check out my factors and multiples video to get a perfectly in-depth description of this. But for now, what we have to do is we need to find the least common multiple of these two values. So what is the lowest multiple of 4 and 32 that they share? Well, 4, let's list some multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32. Oh, look at that. 32 is a multiple of 4. So, and 32 is obviously a multiple of 32. So we have now found the least common multiple to be 32. So what we're going to now do is convert these two fractions to have a denominator of 32. Well, 13 over 32 already has a denominator of 32. How do we convert 3 over 4 to have a denominator of 32? Well, it's going to kind of be the opposite of the simplifying that we did earlier. Instead of dividing by some factor, we're actually going to be multiplying by a factor. Remember, we want our denominator to give us a denominator of 32 here. So what we're going to do is we're going to multiply by some number that takes 4 and gives us 32. That number is 8. We're going to multiply 4 times 8, and that gets 32. But we're also going to multiply by 8 over 8. The reason we're multiplying by 8 over 8 is just 1. Whenever we multiply by 1, the value of something stays the same. If you multiply any number by 1, it doesn't change its value. But we're doing this in a unique way. The reason is we want to kind of anti-simplify this fraction of 3/4. So what we're doing is we're multiplying it by 8 over 8, and we're going to get 24 over 32. So what we've now done is we've shown that 3 over 4 is equivalent to 24 over 32. But what can we do with this information? We now can add 24 over 32 and 13 over 32 directly because they have the same denominator. That was our whole goal with this least common multiple strategy. So now we can add it directly just like we did with that first practice example up here. 24 plus 13 gives us 37. So 37 over 32 is our improper fraction answer, or just 1 and 5/32, using that technique we talked about earlier in this video to convert from improper fractions to mixed numbers. So 1 and 5/32 would be our answer. That's how we add fractions. Subtracting fractions works exactly the same way. If they have a common denominator, if they have a denominator that's the same, for example, 5 over 12 and 2 over 12, like this, right? We can subtract them the exact same. Let's say we were doing 5 over 12 minus 2 over 12. This gives us 5 minus 2, which is 3 over 12, which we can then simplify by dividing each number by 3 to convert us to 1 over 4. So this would be our answer for 5 over 12 minus 2 over 12. And if we wanted to subtract fractions with different denominators, we do the exact same technique. We're just going to find the least common multiple of the denominators to give ourselves a common denominator and then subtract them. The thing with that is we can get negative numbers when we subtract fractions. For example, 3 over 8 minus 5 over 8. Well, this is just 3 minus 5 over 8, which is negative 2 over 8. This is totally fine, right? This is just like working with integers, except for we have a denominator kind of floating with us. So negative 2 over 8, we can simplify it just like we would 2 over 8. We divide by 2 on both in the top and the bottom, and we're left with negative 1 over 4. That's a simplified version, okay? So don't be scared of negative numbers with fractions. They're perfectly normal, and they come out of equations just like this all the time. Now, let's discuss multiplying and dividing fractions. Adding and subtracting fractions is a little bit difficult, but multiplying and dividing actually is much easier. Typically, we think of when we multiply something, it's harder than adding. But with fractions, it's kind of the other way around. Adding is the hard part, and multiplying is the easy part. So let's say we have any two fractions. Proper, improper, doesn't matter. Let's say we have 3 over 7, and we want to multiply it by 5 over 8. How do we do this? It's very simple. Multiplying, we're just going to multiply the numerators and multiply the denominators. So 3 times 5 gives us 15, 7 times 8 gives us 56, and that's going to be our answer. Okay? Now, you might be asking, well, how do we know that can't simplify? That's a great question, right? We can't really tell immediately whether 15 over 56, whether you can simplify it or not. You have to find all the factors, see whether there's any greatest common factors greater than 1, and then we can divide by that value. But we can actually do our simplification before we do the multiplication to make sure that we are left with any simplification errors at the end. What I mean by that is, let's say we have 17 over 25 times 10 over 17. Well, what can we do with this information? We could directly 17 times 10 and 25 times 17. And we get this kind of large fraction, and we'd have a little bit of difficulty seeing whether we can simplify it. Instead, what we can do before we do the multiplication is we can cross off, or we can simplify things that are already here and already shown to simplify. Well, we know that we have a 17 in the numerator here and a 17 in the denominator. We know that 17 divided by 17 is just 1. So if we cancel these, we can reduce these two numbers to be just 1 each. We don't have to worry about them anymore because they cancel each other out, 1 in the numerator and 1 in the denominator. It's like saying you have 17 slices of a 17-slice pizza. You don't have to make it that complicated. It's just one whole pizza. Okay, so we can simplify that. There's another thing we can simplify. 10 over 25 is what we have, but we also notice that 10 over 25 can be simplified to be 2 over 5. What we did was we divided by 5 with each number. And that's totally fine as long as we're doing it in the numerator and the denominator. Don't just do one thing in the numerator and something else in the denominator. As long as we're consistent about what we do in the numerator and denominator, it's totally fine to simplify like this. So now our fraction multiplication has become much simpler. It's 1 times 2 divided by 5 times 1, which is just 2 over 5. And that's a very simple, easily simplifiable, and this is the correct, fully simplified answer. So you can always simplify before you do the multiplication to make your life a little bit easier. Okay? Now, let's get into division with fractions. What do I mean by division? Well, let's do the exact same thing we did earlier. 3 over 7 divided by 5 over 8. Okay, let's talk about what division actually means. It's a little bit difficult to kind of rationalize in our head why we're cutting 3/7 and we're dividing by 5/8. Like, how does this work with a pizza analogy? It gets a little bit too complicated to kind of think in analogies form, but we can kind of convert ourselves to a multiplication standpoint to make it a little bit easier for us to understand. We can write this same fraction as 3 over 7 divided by 5 over 8. Whenever we see something like this, there's one technique that we want to do. It's called the keep, change, flip method. Now, keep, change, flip. Keep that in your mind because it becomes very important. What we do is if we want to divide two fractions, we take the numerator and we leave it as is. 3 over 7. We keep the numerator. Keep, okay? Then what we're going to do is we're going to flip the denominator. We're going to change the division sign to a multiplication sign. So we're going to change division to multiplication. Instead of doing division, we're going to do multiplication now. That's the change part. Change. And we're going to flip the denominator. Flipping the denominator means instead of doing times 5 over 8, we're going to do times 8 over 5. Right? This works because dividing by something is the exact same as multiplying by its reciprocal. So the reciprocal of 5 over 8 is just the 8 over 5 value. So now we can do this multiplication just like we had been practicing earlier. And what are we going to be left with? Well, 3 times 8 is 24. 7 times 5 is 35. So we've just simplified this division into some easy multiplication just like this. Let's do one more practice example to make sure we understand here, okay? Let's say we have 13 divided by 40 divided by 7 over 8. Well, how do we do this? Well, we're just going to do the keep, change, flip. We're going to keep this, so we're going to do 13 over 40. We're going to change our sign. We're going to do, instead of division, we're going to do multiplication. And then we're going to flip our divisor, our denominator, or to make it 8 over 7 instead of 7 over 8. Now, can we simplify this? It looks like we can because 8 goes into 40. How many times does 8 go into 40? 5. So we can convert 8 over 40 to 1 over 5. So let's do this multiplication. We get 13 times 1 is 13. 5 times 7 is 35. And we're left with 13 over 35 as our simplified fraction. Okay, I hope this overview, this in-depth overview of fractions was very helpful. If you do have any questions, leave them down in the comments. Remember to go review the first fraction video if you have not yet, and go review that factors and multiples video to make this explanation a little bit more clear. Thank you, like and subscribe if you can, and I'll see you in the next video.